Hey everyone, welcome back to my channel. Before we get started, don't forget to click the subscribe button if you want more videos about coding interviews. So in this video, we'll be discussing and solving the problem of finding the longest palindromic substring. So let's get started. So the problem is that they give us a string S and they ask us to return the longest palindromic substring in this input string. So a string is a palindrome if it's read the same backward as a forward, and a substring is a contiguous non-empty sequence of character within a string. For example, if we have this input string, the longest palindromic substring is BAB or ABA. The two are valid anywhere, and if we have this input string, the longest palindromic substring will be the 2B. And also if we have only one character, for example B, is also considered as a palindromic substring. So the brute force approach to solve this problem is by checking whether each substring is a palindrome or not, and we will do that by running a three-nested loop. The outer two loops picks all the substring one by one by fixing the corner characters, and the inner loops check whether the picked substring is a palindrome or not. So the problem with this solution is that it's not efficient solution because it have a cubic time complexity. So the best way to solve this problem is by using the expand around the center technique. So this technique is based on the idea that a palindrome has a mirror image in the middle, or in simple terms it can be read the same forward and backwards, so it's like a mirror. So for example, if the length of the input string is odd, the center is at letter C, and if the length of the input string is even, then the center is between the two letters B and B. And once we are at the middle, we can easily check if the letter around the center are exactly the same, so that's what we mean by expanding around the center. So the algorithm that I try to implement in order to solve this problem is that we're gonna loop throughout the input string, and each time we're gonna consider each letter as if it was like the center, and then expand around the current center and check if it's a palindrome. So the reason why this solution is better than the brute force solution, it's because we're looping over the input string and checking every center in the string, mean each letter. Well, in the brute force approach, we was checking every substring if it was a palindrome substring. So as I explained before, that the center of a odd substring is a letter, and for the even substring is a between two letters. For example, let's say we have this input string. To begin, we will start with the first letter B, and we're gonna consider it as a center and expand around it. We will have the two pointers, one value at the left of the B and one pointer at the value to the right of the B. So since the first letter of the string is B, this means that on the left we are out of the string, so the longest palindromic substring with the center as letter B is B itself. Next we move to the next character, which is A, so the center will be A, so we'll expand around the current center. The left pointer will be at the letter B and the right pointer will be also the letter B. Then we are going to check if it's a palindrome. So since B is equal to B, the substring is a valid palindrome, then we're gonna expand around the center another time. So the left pointer will be at the left of the letter B and the right pointer will be at the letter A. So since the left pointer are out of the string, the longest palindromic substring with the center as A is BAB. So before we move to the next letter, what about the center that was between the letter B and A? Because we say at first that the length of the substring, if it's odd, the center will be a letter, and if it's even, the length, the center will be between the two letters. So here we will check also the center between the B and A, and we'll use the same logic, except the left pointer will be the letter B and the right pointer will be the letter A. So since B is not equal to A, we will not update the longest palindromic substring, and we will keep looping over the string. So then we move to the letter B. So B is a palindrome. We expand around it by pointing to the left pointer at the letter A and the right pointer at the right of the letter B, which is the letter A. So since the letter at the left is the same as the letter at the right, means it's a valid palindrome, we will expand another time by moving the left pointer to the letter B and the right pointer to the letter D. So here the letters are not equal to each other, so the current longest palindromic substring is ABA. So we update the longest palindromic substring because it's have the same length as the previous one, so the current longest palindromic substring is ABA. Then another time we check the center between the letter A and B. Since the letter A is not equal to the letter B, we will not expand around the center, we'll move to the next letter. So moving to the next letter, we have the letter A, which is a palindrome because we consider a single letter as a palindrome substring. Then we will expand around it by pointing the left pointer to the left letter B and the right pointer to the right letter D. So since the two letters are not the same, we're not going to expand around the center and also not updating the longest palindromic substring. Then we check if the center between the letter B and A, the same time we will not have a palindromic substring. Finally, we move to the next letter D. So since the right will be pointing out of the string, we will only check if it's a palindrome around the center between the letter A and the letter D. So it's not a palindromic, so we return the longest palindromic substring that are equal to ABA. So it's depend on the details question. If they ask us to return the first longest palindromic substring, we will return the substring BAB. But in this question, they just ask us to return the longest one, so we're gonna return the last one. So the time complexity for the solution is often where n is the length of the input string, and it's because we are looping over the input string, and at each iteration we're expanding 2 times the first time when the center is at letter, and the second time is when the center is between the letters. Well, the space complexity is of 1 because we are not using any data structure to store the result, and we'll use only constant amount of additional space regardless of the input string. That's it, guys. Now let's start coding the solution. So first we start by initializing the current longest palindromic variable to be a tuple with value 0 and 1, which represent the first character in the string as a palindrome of length 1. Then we will loop over the string starting at the second letter. So we start by the odd length palindrome. We initialize a variable called odd palindrome and set his value to the return from call to the function expand around the center that will have 3 arguments, the input string and the previous index minus I minus 1 and the next index I plus 1, which they are representing the left and the right pointers. For the even length palindrome, we set the value to be the return of the call of the function expand around the center that take also 3 arguments, the input string, the previous index as the left pointer and the current index as the right pointer, so that we can have the center between them. So each call to the expand around center, the return will be a tuple representing the longest palindromic substring that can be found starting at the left and right given pointers. Then we initialize another variable called longest palindrome that determine which one are the longest between the 2 palindromes based on the difference between the end and start position, and we will do that using the lambda function in Python. After that, we will compare the current longest palindromic substring to the previous one and determine which one is the longer, and we are going to do that using the lambda function. So once the for loop has finished iterating over all the character in the string, we return a substring of the input string that corresponding to the longest palindrome. And at the end, we define the expand around the center function that takes 3 parameters, the input string and the left pointer and the right pointer. Then we expand around the center by setting a while loop that works only if the left is not outside the string and the right is not also out of the string. And the left letter and the right letter is the same, so we move the left pointer to the previous letter and the right pointer to the next letter. So once they are no more expanding, we return a tuple that represents start and the end of the palindromic substring. That's it, guys. That's for the code explanation. I hope this video was helpful in understanding how to solve the longest palindromic substring problem using the expand around the center technique. So if you have any questions or comment, please leave them in the comment section below, and don't forget to like and subscribe to my channel for more videos and coding interviews. Thanks for watching, and I will see you in the next one.